there's a little bit of boilerplate code here, which basically sets up, so it reads the command line arguments and sets up virtual time if I want it, and then creates an instance of this join test and then runs it basically. And right now I don't have any tests defined in this class. So if I run this, this will be my output, right? So we have real-time 0, simulated time 0, 0 test cases selected, everything is okay. So if I now take this test case, and I think I have it. Let's do a very simple one at first. So let's just do check for the join. So basically, I say I want to join and I want to see an uplink, because join is not complete until you see the uplink, and then that's it. So maybe that was too quick. So wait for join, wait for uplink, done. The test framework will check all the crypto stuff and the frequencies and so on if that is in the region and so on. That's all done by the test framework for you. You don't have to do that for every uplink. And then I just do a test, and down here you can see we simulated 5.3 seconds. That's about how much time it takes for a join to happen and an uplink. And in real time we didn't spend any. And you can see here in blue, this is all the debug output from the simulation. So everywhere there is a debug printf. So we have a world, for example. The LoRaWAN monster will print out all the events that it generates. And then here in teal, you can see the actual data that's going back and forth. So you can see when it starts, the timings, frequency, all these rated parameters, then the actual data, and then it's parsed out. So this is a join request, and it has RFU and major field set to 0, the device EUI, join EUI, the dev nons, and the meter. All has to be parsed out for you. And then once that's done, we can see that the network generates a response exactly 5 seconds later. So if you see this is exactly 5 seconds apart, and here's your join accept with these parameters. And then in the simulation, we get a join event, and then we start our transmission of our first uplink, which has this data here, which is hello. And that's it. So this is how you can write a simple test case. And I've created 3 of them. One of them I already showed. So this is the uplink test that does this in loop for 5 times, and checks the timings, and then there's another one that sends a downlink. And now in the test application, nothing happens when you send a downlink, right? So there's nothing that we can really test, but we should at least see that the downlink is printed out because there's a debug printf statement in the downlink. So if I run this now, now we already used some more time, right? We have 53 seconds that passed for this test in simulated time. And you can see, for example, here is where it does the 5 ones in a loop. And then now here we do, on the last one we do a transmit, and then we have a downlink, network to device, and we see here that the device actually received it and printed it out. And the cool thing, I mean, this is all little stuff, but so for everything that I implement on a device, I write a couple test cases, then I have to go to the physical device to actually test it, and have much quicker turnaround for certain things. And then once I have the test case, I can always run it, and because it doesn't take a lot of time, it just stays there forever, and it just gets run every time I do a build or a release. I just run it.
Are you able to simulate external pins, toggling, or things like that?
Yeah. So we have simulation at the moment for UART and for GPIOs. There's examples in there, and probably we'll have some more pretty soon. Yeah, but for UART. For GPIs.
It would be good for ADC too.
Yeah, sure, yeah. Mm-hmm. Yeah, and the really cool thing is this here. So there's a test target in this make file, which basically just runs, and this is part of the code that's on GitHub, that runs the entire certification test suite, which basically just runs through all the Mac commands and all the read channels and delete channels and so on. And basically, this validates the stack, right? This doesn't validate your application, but it validates the stack. And there's a lot of things that are happening here.
So is the test framework open source as well?
Yeah, so that's inside of,
Okay.
yeah. It's in, so the test framework is something that we're actively working on quite a bit. So it's in there. It's in there kind of silently. So it's mentioned in the Getting Started guide because we showed how to run the test suite, but we don't have any page on how to make use of it yet. But that will come. As soon as you start, we have to be kind of careful because this is something we're working on actively. So we want to still have the freedom to change things a lot. And as soon as you put stuff out there, you limit yourself a little bit. But yeah, so this is a good example. So we've run 1 hour and 15 minutes worth of tests in a few seconds. That's what's kind of nice about the simulation. And like I said, the certification test simulation and the make test is available on GitHub. What I just typed in is very small. It's not on GitHub, but you get the idea.